Good morning, good afternoon, and good evening, ladies and gentlemen. This is Vincent Tan speaking. This time, I'm going to talk about condenser unit, also called Unix refrigerant cycles. At the same time, I also provide the corrective subtitle for your better understanding.
This slide is the most complicated A-series 60K refrigerant cycle. So you can find that this is the pH diagram, and here is the out unit and the in unit. They just connect by the thermostat, either from grid or from third party. It is okay. And let's focus on the out unit. You can find that we have the compressor, two pressure switch, and also this pressure sensor. It is not located at the discharge of the compressor, and we put this here just to detect the pressure, which is low pressure in cooling and high pressure in heating. And after the four-way valve, we will find the condenser, and also there are two EXV. Between them, there is an accumulator, and we go to the indoor unit. First, we find the thermal expansion valve, short for TXV, and then the evaporator, and then we go back and find this gas liquid separator. And also there is a electromagnetic valve here. And first, I will introduce the cooling mode. So from the compressor, the hot gas will comes out. It is actually the high pressure and temperature gas. Then we go to the condenser to release heat. Then the gas will become liquid, but the pressure is no change, which means this is the high pressure but medium temperature liquid. Then we go through this EXV, these two EXV, but the refrigerant is not get expanded, which means here is not the metering device. When it get expanded is at this thermal expansion valve, this one, and then after getting expanded, it will become low pressure and temperature liquid and go to the evaporator to absorb heat, which is doing cooling. And then itself will become gas and flow back to the outdoor unit, and then to the gas liquid separator, then to the compressor after it get separated. And also just pay attention this one, the pressure sensor here detects the low pressure, and also you will find that during cooling, this electromagnetic valve is fully closed because we don't apply the EVI in cooling mode. And also I put this pH diagram here just for your reference. Okay, and next we will focus on this thermal expansion valve, short for TXV. Actually, the standard one it is non-bleeding type, and for the bleeding and non-bleeding, actually it is for the on-off compressor. And what does it mean? It is here you can find that the bleeding, also called hard shut off TXV, it is during the system turn off or at standby mode as we just stop the compressor, and then the control logic of this TXV is depends on this one, which is depends on the superheat of this evaporator. If you turn off this compressor, the superheat will become zero, right? And also this TXV will also to make it to be fully closed, and which is during the off or the standby. That's fine, it's okay. But what is the consequence? It is that the pressure, which is at the left and right for this case, they cannot make equalize, and which is difficult for the compressor next start up, especially for the on off. And at that time, during the startup, the on-off compressor, the current will become much more higher, and always it require special equipment to lower this noise, to lower this current. And as the our compressor, the flex compressor is inverter, so we don't have this worried. And besides, our standard part of this TXV is non-bleeding. On the other hand, is the auto unit and indoor unit, there's no communicate, which means the auto unit just apply the preset logic to operate, and also means it cannot get the information of the indoor unit, means it don't know whether the indoor is too cold or too hot, right? It just apply the command from this thermostat, and also means it can only detect the pressure, which means there is some delay to get the indoor information. Next, we'll go to the heating cycle. And for this case, the refrigerant from the compressor will go to indoor unit first, then hot gas become liquid, but still high pressure. And then it will go through this TXV, but not get metering. And it will just get metering at the outdoor unit, which is this 2EXV. And we divide into two is just to make this one. And if the outdoor and bin it is high, then which means no need the EVI, then we just make it as a regular heating device, which is we just get metering at this two, and then from here it become the liquid, and then get through the condenser to absorb heat, then from this four-way valve and to the gas liquid separator, then to the compressor. And also pay attention to this pressure sensor. This time in heating mode, it detects the high pressure, right? And also here is the pH diagram. And when the outdoor end bin is low, for example, currently it is -5 degrees Fahrenheit, then it requires EVI. And how to adopt it is from this accumulator. There is another out from it. Then we just control by this electromagnetic valve, also called solenoid valve, to inject this vapor from the accumulator to the compressor to higher the refrigerant flow. And from the pH diagram, it will become this one, which means it will higher the high pressure. Then we can get a higher indoor unit air discharge. And also for the injection, for this part, we can also lower the compressor discharge. And for this one, we can higher the compressor reliability. And also for this part, we can extend to bit here, which we can get a higher capacity. This slide is the pros and cons between communicating and non-communicating system. And I just compare GREE, these two models, and with this two model, which is the FlexX. So from the wiring, you can find that this one outdoor unit do the wire to the indoor unit, and then from the indoor unit, it do the wire to the wired controller. And which means this outdoor unit can fully understand the require of this indoor unit, because from the indoor unit it will transmit the information including the temperature and also the indoor unit capacity to this outdoor unit. Then it can make fully understand the indoor situation. Then it can operate the best solution or best compressor output to fulfill or to satisfy customers' need. And just compare with the non-communicating. So the wiring is we need to use this one, this 24-volt wire to this thermostat. And the outdoor unit, you don't know what is the indoor unit, and also it cannot get the information from indoor unit. It just apply the preset operating logic to operate. So from the capacity and performance comparison, this one is higher and FlexX low. And also the precise control, which is refers to the first output, fast cooling and fast heating. This available. this not available. And maybe you can also set on the auto unit PCB to turn on the fast cooling and fast heating. That is based on the preset logic, which means you ask or you require this auto unit to operate in fast cooling and fast heating. Then it cannot slow down. Okay. As for the noise level, and for this one is it can understand the indoor situation, then it can be lower, but this one is high. And also the operating cost, and for this one it is low because it can get the information from indoor unit. It is ongoing transit, which it can make ensure it can dynamic optimized. But for FlatX, it is high because we just offer a few preset options for the end customer to choose. And for the end user control, this one is absolutely higher. And also the error notification, because it don't know the information of if indoor unit, this one. So this one is quick and also in time. And the cost, that means the unit cost for this one is of course higher. And so this is the props of this one. And as for the comms, and this one only need to use exclusive wired controller and also exclusive indoor unit and outdoor unit, which makes it not accept third-party thermostat or third-party indoor unit and outdoor unit. But for this one, available. As for the wiring, this is super simple because basically there are just two wires, and it is ISO Wi-Fi communication. But for this one, the installer or the service person need to memorize the functions of different wire. Also, this requires basic training.
At last, I'd like to emphasize that this comparison is just between these two times and compare with the traditional on-off the tie system. Both of them are much lower at cost and also much comfort in customer use.
That's all for this sharing. If you still have any other question, just feel free to contact me on my personal email address. Hasta la próxima!